We hear about acids all the time, right? Acid rain, stomach acid, the acid in your car battery, it's everywhere. But in chemistry, pretty much everything has an opposite. So today, we're going to talk about the other side of the story, the fascinating counterpart to the acid.
So let me ask you, what is the chemical opposite of an acid? If you're drawing a blank, hey, you are not alone. It's one of those things we don't talk about nearly as much, but that's all about to change.
Because here's the thing, you really can't understand one without the other. The story of a base is completely tied to the story of an acid. Think of them as two sides of the very same chemical coin.
All right, it's time for the big reveal. Let's meet the base, which is also called an alkaline substance. This is the official chemical counterpart to an acid, and I promise you it's hiding in plain sight all over your house.
Okay, so what makes a base, well, a base? Let's get to know its character a little bit. We're going to build a kind of profile for these substances to figure out what truly defines them. What are their core traits?
So here it is, the scientific definition. A base has a pH value over 7, and don't worry, we're going to dig into what that means in just a second. And it has this special ability to produce what are called hydroxide ions when you put it in water. Those little ions, that's their chemical secret sauce. That's what gives them their power. And they have some really distinct signature traits. For instance, if you've ever felt that slick, slippery feeling of soap on your hands, you've felt a base. They also tend to have a bitter taste, but please, definitely do not go around tasting things to check. In the lab, they turn red litmus paper blue, which is the exact opposite of what an acid does. And just like acids, the really strong ones can be pretty corrosive.
Okay, so how do we know how strong a base is? How do we measure it? Well, for that, we turn to the MVP of chemical measurement, the pH scale. It's basically a spectrum that tells us just how acidic or how basic something is.
Now, the pH scale runs from 0 all the way up to 14. Right there in the middle, at 7, is neutral. Think of pure water. Acids, they live on the low end of the scale, from 0 up to 6.9. But bases, oh, they own the entire top half of the scale. And the rule is super simple. The higher the number, the stronger the base.
And you can really see the difference here. On the left, you've got your weak bases. Their pH is maybe 8 to 10. These are things like mild cleaners, even some foods. They're generally pretty safe to handle. But then, look at the right side, the strong bases. We're talking a pH of 11 to 14. These are your heavy-duty cleaners, the serious disinfectants that can be corrosive and really need to be handled with care.
Now that we know what they are, let's bring this all back home. Literally. You're about to see just how many of these substances are hiding in plain sight, probably right under your sink or in your pantry.
No, I'm totally serious. I'd be willing to bet you've already used a base today. Whether you washed your hands with soap, brushed your teeth, or maybe cleaned up a spill in the kitchen, you've almost certainly interacted with a base without even giving it a second thought.
Just look at this lineup. It's incredible. We start with something gentle like baking soda, a really weak base. Then we move up to soap and milk of magnesia. Yep, that's a base you drink to calm down stomach acid. As we keep climbing the pH scale, we get to the heavy hitters. Ammonia, a super powerful cleaner, and then all the way up near the top, you've got bleach, a very, very strong base we use for disinfecting.
So, we've met the acids, we've met the bases. What do you think happens when these two opposites finally meet? Well, this is where the real chemical magic happens. It's a process with a really cool name, neutralization.
This right here is the whole point. It's the most important thing to remember. When you combine an acid and a base, they don't just sit there together. They react, and they actually cancel each other out. The acid becomes less acidic, and the base becomes less basic. It's a chemical truce.
The whole process is kind of like a simple 3-act play. Act 1, you mix an acid and a base together. Act 2, their opposing properties clash and they neutralize one another. And for the grand finale, they transform into something totally new and stable. Usually it's just plain old water and a type of salt. And look, this balancing act, this neutralization, it matters so much because it's happening everywhere, all the time. It's how antacids make your stomach feel better, it's crucial for manufacturing all sorts of products, and it's even happening inside your own body right now to maintain the perfect pH balance that keeps you alive.
So, let's end with a little pop quiz. After everything we've just talked about, if you see a substance with a pH of 12, what does that tell you? Is it a weak base, something you might bake a cake with, or is it a strong base, something you'd use to disinfect your bathroom? Go on, think about it. The answer tells you everything you need to know about its power.